Double slits. The first double slit experiment was devised by Thomas Young in 1801 to demonstrate that light has wave-like properties. Light or electrons passing through both slits interferes with itself, produces wave-like patterns on a screen set up behind the slits, clear proof that light behaves like a wave. It took more than 100 years for physicists who performed the same experiment to realize that light can behave like waves or particles, depending on something very strange. When unobserved, the light behaves like waves rippling out from both slits. These waves interfere with each other just like waves do on the surface of water, producing lows where waves cancel each other out and highs where the waves add together. This is called superposition. Where the waves are in superposition, they show up on the screen as a series of photon impact bands, which decrease in magnitude from the center. This is exactly how we expect waves to behave. The strange thing is that if you observe the light closely and can see which slit the individual photons go through, call it slit A or slit B, then all of those photons behave exactly like particles and hit the screen directly behind slit A or slit B. This is exactly how we expect particles to behave. The act of observation somehow changes our reality. Quantum physics began when Planck, Einstein, de Broglie, Compton, Bohr, and others realized that light fundamentally has an irreducible dual nature, which they called the wave-particle duality of quantum theory. Quote, "For those who are not shocked when they first come across quantum theory cannot possibly have understood it." End quote. Niels Bohr, who lived from 1885 to 1962. Since that time, physicists have performed the double-slit experiment, always getting the same wave-particle duality, with photons, electrons, and even molecules, some quite large. Matter has a dual nature. How large? A recent experiment found that molecules 10,000 times as heavy as hydrogen, with 810 atoms in a single particle, can behave like particles or waves in the double-slit experiment, depending on whether they are observed or not. Think about that for a sec. Individual large molecules can pass unobserved through both slits as a wave and hit the screen in an interference pattern, time after time. But if we see which slit any given molecule goes through, then it will always hit the screen where a particle would, directly behind slit A or slit B. The quantum eraser experiment. The fact that observation is what determines whether photons, electrons, or molecules will behave like particles, observed, or waves, unobserved, in the double-slit experiment has really unnerved people. Physicists have recently tried to remove the observer as much as possible in a related experiment called the quantum eraser, to probe what observation really means. In this setup, which I have drawn up and simplified as much as possible, there are 4 detectors which act like the old-fashioned screens in the original double-slit experiments. A prism is put behind the slits to bend the light coming out of slit A and slit B to make enough room for the apparatus. 3 beam splitters each have an equal chance of either reflecting or transmitting the light. The 2 mirrors always fully reflect the light. As it turns out, the first 2 detectors above, D1 and D2, always detect impacts consistent with particles, while the second 2 detectors, D3 and D4, always detect impacts consistent with waves. Why? This clever experiment tries to remove the observer, but it only manages to shift observation later in time. The reason D3 and D4 always detect waves is because we cannot determine which path the beams took, due to the clever geometry of the experiment. D3 and D4 each have a 50% chance of detecting light that passed through slit A or slit B, and therefore this light behaves as if it was unobserved, as waves. D1 and D2 always detect particles, and because of the setup, we know that all the light entering D1 went through slit A, and all the light entering D2 went through slit B. Somehow this knowledge is equivalent to observation. If we can know, even after the fact, which slit the light went through, then it will behave like a particle. If the knowledge of which slit the light went through was erased by the clever geometry, then the light remains a wave. So light is a wave until we learn about its trajectory later in time. How does the light, quote, know, end quote, that we are going to learn something about it later, and correspondingly change its behavior earlier in time? Delayed choice quantum eraser. Seeing all this, the physicists got even more clever. They added a special set of prisms and lenses that produce entangled photons, which enter another D0 detector before the later detectors D1 through D4 described earlier. The strange thing is, whether light acts like a wave or a particle is predicted by entangled photons before the light has a chance to get transmitted or reflected at the beam splitters. The entangled photons as waves or particles at D0 match up perfectly with what nanoseconds later gets detected at D1 through D4. So the light knows what is going to happen in the experimental apparatus well before it happens, and light behaves as a wave or a photon accordingly. It somehow knows whether we are going to get knowledge about it in the future, and ensures that it behaves like an unmanifested, spread-out wave, or, if necessary, as a collapsed, deterministic particle. They call this retrocausality, and it is controversial because causality is such a basic common sense idea that we find it very hard to believe that reality might have effects preceding causes. Maybe time isn't linear, or everything happens in the eternal now, and that somehow time is an artifact of perception? These experiments should teach us something about the nature of reality. Light, charge, and matter remain spread out waves unless they are forced by observation to be localized particles, independent of time. In my view, I speculate that the mechanism that forces this change of representation is the transfer of information from world mind to soul mind. It must be that information can only pass through dissociative boundaries as discrete numbers, ones or zeros, for example. When information is inside world or soul mind, it can remain quantum, indeterminate, either, neither, both, one, or zero, because thoughts are unmanifested, spread out possibilities, like waves, rather than manifested concrete objects that can be weighed and measured, like particles. We experience the world as something concrete, manifested, objective, because all of our information about the world must pass through and enter into our soul's dissociative boundary, and thus becomes shadows of the vital subjective reality of world mind, what we call our perceptions of the world. It's all a bit like Plato's allegory of the cave, where waves are the true reality outside the cave, but particles are the shadows the prisoners inside the cave can weigh and measure, so they mistakenly assume shadows are the only reality. We have known better for 100 years, but the implications have a way of taking a long time to sink in. Quote, I regard consciousness as fundamental. I regard matter as derivative from consciousness. We cannot get behind consciousness. Everything we talk about, everything that we regard as existing, postulates consciousness. End quote. Max Planck, who lived from 1858 to 1947. Particles and concrete determined objective physical reality may be an illusion as seen through our own double slits of perception. True reality is wave-like, quantum indeterminate, brimming with infinite possibility. Let us stop being prisoners and see beyond the shadows to the illuminated, non-localized source of being, consciousness.